In this video, we are going to see how to find the Fourier series expansion of the function fx equal to x defined in the interval 0 to 2π. So for that, we have this general rule. The Fourier series expansion of any function f of x which is defined over the interval c to c plus 2l is given by a0 over 2 plus summation n is going from 1 to infinity an cos n pi x over l plus bn sin n pi x over l, where we need to calculate the values of a0, an and bn by using these rules. So for our function fx equal to x defined in the interval 0 to 2π, we need to modify this formula by substituting the value of l. How will we get that? Now our function, what is the width of the interval 0 to 2π? What we are finding? We are finding the width. Let me write it properly. Width. So how we'll find it? It is given by always the upper number minus the lower one. So 2π minus 0, which is equal to 2π. Now this function in the rule, it is defined from c to c plus 2l. So if we want to find width of the interval c to c plus 2l, how it is given by? Again by the same rule, c plus 2l minus c, the upper limit minus the lower one. So this gives you 2l. Now since we are going to use this rule for this function, so we compare these two. 2π equal to 2l. So what this will give you? This will give us a value of l as pi. Value of l as pi. Now we use this value of l all over here. And our function fx is 0 to fx is x, which is defined from 0 to pi. Now, so we write the Fourier series expansion. Fourier series expansion of our function fx, which is x, is given by a0 divided by 2 plus summation n from 1 to infinity an cos n pi x divide, here it is l, here we substitute our calculated value which is pi, plus bn sin n pi x over l, l is again pi, okay, which is equal a0 over 2, we can simplify it, n from 1 to infinity. How we can simplify? Here it is pi and pi. Since it is between the angle, we can cancel it. This is the argument. So we get an cos of nx plus bn sin of nx. Okay, so this is the Fourier series expansion of our function x. Now we need to calculate the value of a0, an and bn by using that rule. So we'll write here where a0 is equal to, first we write the rule, 1 over l, l is pi, integral. Here it is from c to c plus 2l. where the function is defined. Our function is defined from 0 to 2 pi. So we'll get it is from 0 to 2 pi fx dx is equal 1 over pi 0 to 2 pi. Now we are looking for the value of fx. Fx, this value is given in our question, which is x. So we replace it here, x dx. Now this is a simple integration which we can integrate. Integral of x is x square over 2 within the limit 0 to 2 pi. So this will give you 1 over 2 pi. Substitute the limits. 4 pi square. Which one cancellation gives you 2 pi. So we get a naught as 2 pi. Similarly, we need to find the value of an and bn. For an, let's see how to find an. To find an, it is given by 1 over l. L is pi. 1 over pi. Integral c to c plus 2l. In our case, it is from 0 to 2 pi. Fx cos of n pi x over l. L is again pi dx. Further we simplify it. This pi and pi get cancelled. And we substitute the value of fx here by x. So what we'll get? 1 over pi integral 0 to 2 pi x cos of nx dx. Now here we have product of two functions and which we need to integrate. So we can integrate it by parts. Now one of the function is algebraic function, that is x. So we can use the rule, one function for derivative, another for integration, that we studied in unit 1 and unit 2. So this x we keeps on differentiating, and for this we will cos nx we will integrate. So when we do it, for x the derivative is 1 and second derivative 0. For cos, the integration sin nx divide n. Integration of sin is minus cos nx divide n square. So you know this rule, right? Make the sign plus, minus and plus, and then cross multiply. So as there are two arrows, so this term integral will consist of two values. So it is 1 over pi x sin nx divide n, minus minus become plus, cos of nx divide n square from 0 to 2 pi. Okay, this is the calculation we did separately for this one. Now we need to substitute the limits and get the value. So this will be equal to 1 over pi x, first we replace by 2 pi. 2 pi sine of 2n pi over n plus cos of 2n pi over n square. This is when we replace x by 2 pi. When we are replacing x by 2 pi, we need to replace this x and x over here and x over here. Now minus the lower limit. When we replace x by 0, we get 0 plus 0 into sine of 0 becomes 0. Cos of n into 0 is 0 over n square. Okay, which is equal 1 over pi, 2 pi. Now here it is sine of 2n pi and cos of 2n pi. So for this you need to remember rule. Sine n pi is always equal to 0 for all integers value of n, while cos of n pi is always equal to minus 1 to the power n. Okay. So if n, in place of n we have here 2n. So if sine of n pi is 0, sine of 2n pi is also 0. So this will become 0. Divide n plus cos of n pi. Cos of n pi is minus 1 to the power n. If it is, say, cos of 2n pi. So in place of n, here we have 2n. So this value will become minus 1 to the power 2n. Minus 1 to the power 2n. It is always in 2n, isn't always in even numbers. So it is 1. So what we'll get here now is 1 over n square. This value is 0 minus cos of 0 is 1 over n square. So now we can cancel this plus with minus. So we left with 1 over pi 2 pi over n. Again we can further simplify by cancelling pi with pi. So we left with 2 over n. So we get an as 2 over n. Okay, now what is left? It's left to get the value of bn. Similarly, using this rule, replacing the value of L and fx, we get bn is 1 over pi integral 0 to 2 pi fx is x sine of n pi x over L is again pi dx. So again we can cancel pi with pi. So we'll get this is equal 1 over pi integral 0 to 2 pi x sine nx dx. Now again it is an integration which we need to integrate by parts. One of the function is algebraic function, so we can integrate it in the same way. One function is select x for derivative, sine nx for integrating. Derivative of x 1 and then 0. For sine it is minus cos nx divide n. Here integration of cos is minus sine nx divide n square. Then we put the sign plus minus plus and then cross multiply. So its integral is given by 1 over pi minus x cos of nx divide n plus sine nx divide n square. The limit is from 0 to 2 pi. After this step, we need to substitute upper limit and lower limit. Once we substitute it, we will get these two terms, which on simplification gives you the value of bn as minus 2 over n. Because cos of 2n pi, this will be 1. Cos of sine of 2n pi, this value becomes 0. Sine of 0 is 0. So this is the Fourier series expansion with the values of an, bn and a0.